Of all the edible mushroom varieties, white button mushroom is the most popular variety among consumers in India. Even though cultivation technology of many nutritious and specialty mushrooms are standardized, white button mushroom is still dominating the Indian and international market and hence motivates new entrepreneurs to take up the cultivation of this mushroom. The white button mushroom contributes more than 80% of total country's mushroom production and its share is around 30% at global level. Several advances have been made with respect to compost preparation and environment modulation to cultivate white button mushrooms. Many commercial units have been set up by the entrepreneurs and farmers throughout the country for the production of button mushrooms throughout the year. The present video documentary will give the basic understanding about the cultivation of button mushrooms in environment controlled facilities. The costing of the mushroom production unit varies greatly depending on the production capacity. In this video documentary, a unit of 365 tons per annum project is considered for most of the illustrations. Any environment controlled button mushroom unit will ideally have the facility of three components like compost production, spawn production, and insulated cropping rooms with a facility to maintain a temperature of 23 plus or minus 1 degree Celsius during spawn run and 16 to 18 degrees Celsius during cropping period. The compost production facilities include the storage space, the compost yard, phase 1 bunkers, pasteurization tunnels, and a boiler. Now we shall see the requirement of farm design in brief for round-the-year cultivation of button mushroom in environment controlled facilities. For a unit with a production capacity of 365 tons per annum, around 3 acre land is required for construction of civil structures and other infrastructure. 16 insulated cropping rooms with a dimension of 59 feet length, 20 feet width, and 12 to 13 feet height are to be constructed. Each of these rooms can accommodate around 21 tons of compost in one cropping cycle. So totally 330 to 340 tons of compost can be filled in all the 16 cropping rooms per cropping cycle. Under moderate climatic conditions, an air conditioning with 110 ton of refrigeration measured in TR can maintain the desired temperature inside the cropping rooms. To produce the compost required for each cropping cycle under indoor method, 3 phase 1 tunnels with a dimension of 34 feet length and 10 feet width to accommodate 23 to 24 tons of compost can be designed. For phase 2 composting process, 4 bunkers with a compost holding capacity of 58 tons are required. The length and width of each bunker can be in the range of 37 to 41 feet and 12.5 to 14 feet respectively. The fresh air required for conditioning of compost can be achieved by using blower fan of capacity 1000 to 1100 cubic meters per hour. The cultivation technology of white button mushroom involves 5 basic steps, beginning from production or procurement of spawn, compost preparation, spawning, casing, and crop management. The mushroom cultivation is analogous to farming activity in the sense that spawn acts as a seed material and the substrate or the compost acts as a soil base. Spawn is a mass of fungal mycelium grown on cereal grains such as wheat, sorghum, jowar, etc. If good quality spawn can be obtained at a reasonable price, it would be wiser to concentrate on the mushroom growing process alone in a small scale production. But for 365 tons per annum and above, it is better to have own spawn production unit as it helps to cut down the cost of cultivation and ensure the supply of quality seeds. Besides the spawn, the quality of the compost plays an important role in ensuring success in mushroom cultivation. Compost is a physically and chemically homogeneous medium to facilitate the growth of mushroom mycelium and subsequently the mushroom fruit bodies. The compost is prepared by either of the three different methods, such as long method, short method, and total indoor composting method. The long method of composting is a conventional method and generally adopted by the seasonal mushroom growers, where facilities for bulk pasteurization are not available. This method is designed to carry out the complete composting process outdoors by achieving pasteurization under natural weather conditions. The short method of composting is widely followed by the growers who have the facilities for round-the-year cultivation of mushrooms. Besides taking lesser time, the short and indoor method of composting gives higher compost productivity. The short method of composting involves two phases. The first phase involves outdoor composting for 10 to 12 days, then followed by the pasteurization and conditioning in tunnels in second phase, which lasts for 5 to 7 days. The formulations standardized and followed at ICAR Directorate of Mushroom Research Solon in the short method of composting makes use of following materials: wheat straw 1000 kg, poultry manure 400 kg, wheat bran 60 to 70 kg, urea 14.5 kg, gypsum 30 kg. At the beginning of the composting, the cereal straw is thoroughly wetted on the cemented floor. This pre-wetted straw is then mixed with the poultry manure and wheat bran and kept as such for 2 days in a pile. After this, the pile is broken and water is added to the dry portions, and again the stack is made. After another 4 days, the compost is turned and the entire quantity of urea is added and high aerobic pile is made. The stack is again turned and watered after every 2 days, and the gypsum is added in the third turning. During this stage, the temperature of pile will rise to 70 to 80 degrees Celsius on its own. The final turning will be given on the 12th day, when the color of the compost changes into dark brown and it starts emitting a strong smell of ammonia. This indicates the end of first phase. The second phase is the pasteurization and conditioning phase. The compost prepared as a result of microbial fermentation process needs to be pasteurized in order to kill undesirable microbes and competitors. The compost from the phase 1 should be filled in the specially designed pasteurization tunnels to a height of 7 to 10 feet. At this stage, bring down the temperature of the entire compost between 45 to 48 degrees Celsius. Later, the temperature of the compost should rise to 48 to 52 degrees Celsius through the supply of fresh air and maintain the same for 48 hours. After 48 hours, the compost temperature should be raised to 58 to 62 degrees Celsius by inducting the steam and maintain the same for 4 to 6 hours. Then the temperature should be brought down to 48 to 52 degrees Celsius and allow the compost to retain at this temperature for another 3 days. At this stage, ammonia levels should be monitored with the help of ammonia meters near the chimneys. If no ammonia persists in the compost, then bring down the compost temperature to room temperature. At this stage, the final compost should be granular in structure with 65 to 70% moisture content and a pH of 7.5. It should have a dark brown color with inoffensive to sweet smell and completely free from ammonia. Another rapid method of composting developed in the recent time is by indoor method. Compost prepared either by long method or short method involves traditional outdoor composting. But in this method, both phase 1 and phase 2 can be done under indoor conditions. The phase 1 composting is carried out in a specially designed bunkers. Generally, these bunkers are 1.5 times more the size of the phase 2 tunnels with respect to volume. It has a plenum, that is a ventilation duct, and a perforated concrete floor is constructed above the plenum which is serviced by a centrifugal fan having 1/4 capacity of phase 2 blower. The ingredients mixed in the composting yard will be shifted to phase 1 bunkers, and the blower fan should be switched on with 3-minute on and 2-minute off cycle. The compost in phase 1 bunkers should be kept for 3 days and later should be taken out, turned and mixed properly and then shifted to another tunnel. Follow the similar pattern of blower usage and keep the compost for 3 days. After 6 days, the compost will be shifted to phase 2 bunkers or pasteurization tunnels, where same procedure should be followed as discussed in the short method of composting. The next important step involved in the production of button mushroom is spawning. The quality of the spawn should be ensured, as it determines the productivity and profitability of the mushroom unit to a larger extent. Once the compost is ready, it is thoroughly mixed with the second generation grain spawn of desired strain. The spawning activity can be done on the clean and disinfected area. Formaldehyde at the rate of 2% can be sprayed on the area selected for spawning for disinfection. Around 500 gram to 750 gram of grain spawn can be used to spawn 100 kg of prepared compost. Fill the 10 kg of spawned compost in polythene bags of 20 by 24 inches size. The mycelial colonization must proceed as rapidly as possible to prevent the growth of competitor organisms. For this purpose, the moisture content of the substrate should be maintained at 65 to 70% and a temperature at 23 plus or minus 1 degree Celsius. It may take 12 to 14 days for the complete colonization of mycelium of agaricus in the compost. Once the colonization is complete, the mycelium can be made to induce the fruiting stage by covering the surface of the substrate with a thin layer of moist material, mostly of pasteurized soil. This process is called as casing. The casing layer must maintain the mycelial growth, stimulate fruiting, and also should support continual flushes of mushrooms. To prepare the casing soil, mixture of 2 years old farmyard manure and garden soil in 1:1 ratio is ideally preferred. If coir pith is available, it can be used along with the farmyard manure and garden soil in 1:1:1 ratio. The prepared casing soil is pasteurized either by steam at 65 to 70 degrees Celsius for 6 to 8 hours or by drenching with commercial grade formaldehyde solution at the rate of 3 liters in 40 liters of water per cubic meter of casing soil. The pH of casing soil must be adjusted to 7 to 8 with the addition of calcium carbonate, commonly known as chalk powder. Besides pH, good casing soil should have high water holding capacity, high porosity, and it must be nutritionally poor. Uniform depth and evenness are two important factors during the casing of the compost bags. Compost bags with depth of 6 to 8 inches are cased 1.25 to 1.5 inches deep. Substrates deeper than 8 inches are cased 1.5 to 2 inches deep. Spray the water immediately after casing application and thereafter every day. Environmental conditions after casing should be the same as during the spawn running. Substrate or compost temperatures maintained within the optimum range for mycelial growth. Relative humidity is 90 to 100% and fresh air is kept to a minimum. Within 3 days of casing soil application, the mycelium should be growing into the casing layer as well. Once the mycelial growth is firmly established, the casing is gradually watered up to its optimum moisture holding capacity. This is accomplished by a series of light watering with a misting nozzle over a 2 to 4 day period. Once the mycelium is clearly established in the casing material, the cultivator can begin the first step, leading to the setting up of pinheads. Within this 1 to 2 day period, the substrate and air temperatures are lowered to the fruiting range of 16 to 18 degrees Celsius, the humidity is lowered to 85%, the carbon dioxide content of the room is reduced to less than 1000 ppm by the introduction of fresh air, and the room is lighted on a 12-hour on-off cycle. This change in environmental parameters helps to the development of pinning and subsequent development of pinheads into solid fruit bodies within another 3 to 4 days. At this stage, the fresh air should be inducted 4 to 5 times in a day to maintain the CO2 levels at optimum range. The mushroom crop grows in cycles called flushes or bracts. The uniform fruit bodies of 4 to 5 cm in diameter should be hand-picked in a twisting motion. Trim the stem base with sharp knife, removing only flesh to which the casing is attached. Damage to resting pinheads and disturbance of the casing soil must be minimized during picking, otherwise it affects the future flushes. Daily watering is required after harvesting the first flush. 18 to 25 kg of fresh mushrooms can be harvested from 100 kg of prepared compost in 2 to 3 bracts depending on the cropping cycle management in the mushroom unit, strain of mushroom, the quality of the compost, and good mushroom cultivation practices. Hygiene is vital for a commercial mushroom farm. Since chemical control of pests and diseases is not possible in small-scale mushroom cultivation, the ideal preventive measure is through maintenance of hygiene and to some extent disinfection. This also goes for spawn production unit, the site for substrate production, the incubation rooms, and the production units. The capital expenditure for establishing the button mushroom unit with year-round production facility is directly linked with the expected production output. For establishing a mushroom production unit with 365 tons per annum capacity, nearly 4 crore rupees may be required for creating facilities for composting, cropping rooms, and for purchasing of chillers and other machinery. Considering the expected wholesale market price of white button mushroom and the costs incurred in procuring raw materials, electricity charges, and labor wages required for 6 crop cycles in a year, the unit may reach the break-even point in the 4th year. With this, the entrepreneur can earn a net profit of 1.4 to 1.5 crore rupees per annum, depending on the extent of ideal crop management practices followed in the mushroom unit.